Okay, good morning, Algebra 2 students. I'm going to demonstrate to you on problem 10 in the distance learning how we can also recreate the same problem in Excel. So I didn't label this as of yet, but we can do that right now. And I'm going to highlight both these. And again, I'm going to call this input because I think there is some danger in getting hung up on the generic term of X and Y, regardless of what the variables are. It could be P for price, and it could be Q for quantity. That's a standard boilerplate approach for a lot of economics, or a lot of graphs in economics, for instance. However, it's just the generic X and Y in the sense of input versus output. So from the very same graph that we were working with, I just eyeballed each of the ordered pairs for perfect integers, meaning negative numbers or positive numbers, where they weren't sliced up in some way as some kind of fraction, except in the slightly pedantic sense that they were being divided by 1. Pedantic just meaning like almost overly tedious, but to be precise, that all numbers are a fraction even if they're divided by 1. Nevertheless, to get to the point, we have -5, 0, -4, 1, all the way up, so we can recreate the same graph. If you guys don't already know how to do this, in Excel, then I go to Insert, and then over here to Graph, and voila. And if you don't believe me, let's go back to where I used the Snipy tool and copy the graph. And hopefully this shows up in the video. But this is the very same graph. If I can somehow get them side by side. We want to cut that down to size for the sake of presentation. But we have the same relationship. It looks a little bit more elongated here, but that's just a matter of scale. Fact remains that over here where we have, we'll redo that. This would be the ordered pair of where x equals 1, y equals -4, and you can see where x equals 1, y equals -4, or where the input is 1, the output is -4 on this graph. So now you know how you can potentially create some kind of graph. I'm not sure what we would be measuring. Maybe it could be, again, in an economic sense, it could be money you invested in something. You invested $1 and you lost $4. Doesn't matter. There's lots of things you could be doing. You walked 1 mile, lost 4 pounds. Don't know how realistic that example is. In this coronavirus economy, the idea of investing $1 and losing $4 seems eminently realistic, at least for the time being. And we'll get through this, though. We're human beings, and if we know anything about history, to go on a slight tangent, we know that human beings will survive innumerable peril. As we have in the past, we will today. Nevertheless, getting back to the problem, for what x values is the function decreasing? So over here, as x gets bigger, going towards 0, think of everything going towards 0 and then going beyond 0 from negative infinity towards positive infinity, if you want to think of it that way. So over here, as x gets bigger, as x approaches positive infinity, at least between -5 and 0, x or y, x or the input, as the input is getting bigger, the output is also getting bigger, because you see this input at -5 corresponds to 0. So that's the ordered pair -5 and 0. But then at the next ordered pair over here, when x equals -4, we've gone up. We've gone up in this block. So then we have the ordered pair. See, the input is -4, and the output is 1. Well, we went from 0 to 1. From 0 to 1. I'll rewrite that so it's a little bit clearer. -4, 1. So we're getting bigger each time, and then we go up to this point where x equals -3. X equals -3. It's really hard to get out of that habit of saying x and saying input because we're so used to it, but this is an x and this is a y, so I'm being pedantic. So when x is -3, y is 2, right? So 0, 1, 2. We have a 1-to-1 relationship right now. It's a straight line, and it's getting bigger. X is increasing. The question is, for what x values is the function decreasing? So we know at the very least it wouldn't be anything characteristic of these points. So where x is between -5 and -2, nope. So this is had an economics professor that used to go through something like this, shading in all the different, and the textbook did the same thing, shading in all these little triangles that were encompassed in the graph. There's a whole idea of welfare economics that comes out of that analysis that we won't go over. Okay, I'm trying to get that nice and black. But that triangle would be between x, where x is greater than -5 but less than -2. And we can X that one off. That doesn't work. Next one, where x is between 0 and -3. 0 and -3. Well, does that make any sense? Between where x is greater than 0. Oh, I think I'm looking at C, where x is greater than 0 but less than 3. So, and the question is, when is the function decreasing? Well, we can clearly see that as x goes from 0 on up to 3, it is still decreasing within that area. So we can put a star there. It's more like an asterisk, but you don't want to see my star. I'm not going to attempt to draw a star. An asterisk I'll do. Okay, so we've got an asterisk. call it a star. So that would work. Where x is greater than 0 but less than 3.5. Let's see, this point here is 3 on the x-axis. Over here, it looks like it's increasing when x is between, forget 0, but when x is between 3 and 3.5, or for that matter, between 3 and 4, between 3 and 4 over here, x is getting bigger, so, or y is getting bigger. When x is between 3 and 4, y is getting bigger, so that one doesn't really make any sense. And then we've got b between -2, when x is greater than -2 and less than 1. -2 is over here, and 1 is over here, because it is decreasing between this whole point here. This whole point, it's increasing, or decreasing, I mean. And actually, going back to this one, to C, that is, when x is greater than 0, but less than 3, actually, once we get beyond 1, x isn't really increasing or decreasing, it's really just stagnant. It's neither increasing nor decreasing between 1 and 3. So that one never really did deserve a star. This one not only deserves a star, it deserves a check mark. And cross that one out as well. So we're left with B for Bravo, where x is greater than -2 but less than 1. And that's all she wrote.